This is Calculus 1 video lecture number 19 on hyperbolic functions. Now, hyperbolic functions are a result of even and odd combinations of e to the x and e to the negative x. And they have the same relationship to the hyperbola that trig functions have to the circle, to the unit circle. So hyperbolic sine is defined as follows. It's equal to e to the x plus e to the negative x, all divided by 2. So notice here we have the graph of e to the x over 2, negative e to the negative x divided by 2, and then if you add those together in pink, you have hyperbolic sine. Instead of saying hyperbolic sine every time, because it's kind of a mouthful, you can say sinh, okay? Sinh of x. And pretty much math people will know what you're talking about. So that's the graph. I mean, it kind of looks like x cubed, right? Just to get a general picture in your head. That's where it's coming from. Okay, we've got a hyperbolic cosine. Oh, yes, we do. Only difference is now you're adding together both powers of e. So you have e to the x plus e to the negative x divided by 2. So here's 1/2 e to the negative x, 1/2 e to the x over 2. If you add them together, you get hyperbolic cosine, which kind of looks like a parabola, but it's not. And its min occurs at 0, 1. Right there. You can see it. Again, saying hyperbolic cosine is a mouthful, so you can just say Cosh of x. Remember the definition for hyperbolic sine and for hyperbolic cosine. Okay, hyperbolic tangent, you get it the same way you get regular trigonometric tangent of x. You take sinh divided by Cosh of x. And so the denominators, the 2's are going to drop out, right? You just have e to the x plus e to the negative x divided by e to the x plus e to the negative x. There's the graph. What does it remind you of? It reminds me of regular tan inverse of x, right? And we've got these horizontal asymptotes, but this time they're at y equals 1 and negative 1. And then similarly, hyperbolic cosecant is 1 over sinh of x. I don't have a good way of saying that. No, I mean, that just doesn't work. Hyperbolic secant, you can say sech of x, right? That's 1 over cosh x. Hyperbolic cotangent of x. That one's a tricky one. No. Cosh of x over sinh of x. Good thing is those ones don't come up too often, okay? Fabulous. So let's just practice getting comfortable with these guys. Probably the first time you've seen them, right? So find the numerical values. So for hyperbolic tangent, remember it's sinh of x over cosh of x. So this is sinh of 0 over cosh of 0. And you need to just use the definition. So remember, sinh was e to the x minus e to the negative x, so over 2. So e to the 0 minus e to the negative 0 over 2. And then the only difference with cosh of x is that it's plus. So e to the 0 plus e to the negative 0 over 2. Okay, so e to the 0, that's 1, minus e to the negative 0, 1 over 2 over, and then this is going to be 1 plus 1 over 2. Now the 2's drop out. I just have 0 over 2, so this is 0. All right, hyperbolic cosine of 3, aka cosh of 3. So this is e to the x, so e cubed, plus e to the negative 3rd over 2. That's it, you guys. That's it in exact form. Okay, if you want a decimal, then plug that guy in your calculator. You should get about 10.07. Love it. Sinh of 1. So e to the 1st minus e to the negative 1st over 2. So this is e minus 1 over e over 2. Okay, let's clear out that complex fraction. So multiply upstairs, downstairs by e. You get e squared minus 1 over 2e. Now that's the exact answer. Okay, lovely. If you want it as a decimal, punch it in your calculator, 1.1752. Okay? Lovely. Now, let's look at some identities here. Sinh of negative x equals negative sinh of x. What does that mean? That means it is an odd function. Okay, so just like regular trigonometric sine of x is odd, so is sinh of x. Cool. Cosh of negative x equals positive cosh of x. So that's an even function. Ooh, look at this one. Cosh squared of x minus sinh squared of x equals 1. This should remind you of cosine squared theta plus sine squared theta equals 1 for trig, right? And remember, that's based on the unit circle because the equation of a circle centered at 0, 0 with radius 1 is x squared plus y squared equals 1. And here we basically have cosh squared of x minus sinh squared of x equals 1. But that's because hyperbolas have a minus sign in their equation, right? Either x squared minus y squared equals 1 or y squared minus x squared equals 1. So this should make sense that this identity has a negative sign. Okay, and then you can derive all the rest just by dividing through by either cosh squared of x or sinh squared of x. So we also have 1 minus tanh squared of x equals sech squared of x. And then here's some angle addition properties. So sinh of x plus y, that's the same as your sine angle addition formula. But look at, for cosh of x plus y, this is addition. When you have your regular cosine angle addition formula, that has the opposite sign. That's not true with the hyperbolics. So just something to keep in mind, okay? If you're one of my students, I don't expect you to memorize all this. Like, know the definition for sinh of x, cosh of x, tanh of x, like we did up above. You need to know that, okay? And then these, as they come up, you can use them, but it's not imperative that you go home and start memorizing all of this. Okay, let's prove some identities here. So let's prove that cosh of negative x equals cosh of x. See, you can do this with the definition. If you just remember what cosh of x is equal to, you're good to go. So remember, cosh of x is e to the x plus e to the negative x divided by 2. Like this, yes, you do need to know. So now I'm just going to substitute in negative x for the exponents and then see if I can complete the proof. That's it. So this would be e to the negative x plus e to the negative x over 2, which is e to the negative x plus e to the x over 2. And see, these guys are the same. It's just the numerator's been rearranged. So I'll switch it just so you can see. Oh my goodness, it's exactly the same. Wow. So this is cosh of x. We are done. Okay. What about the next one? 1 plus tanh x over 1 minus tanh x equals e to the 2x. Let's start with the left-hand side. It's messier. That's usually the way to go, especially if you remember doing little trig proofs back in the day. So tanh of x, let's see, this is 1 plus sinh of x over cosh of x over 1 minus sinh of x over cosh of x. Okay, I can clear out the complex fraction if I multiply everything by cosh of x. And let's see here. So upstairs, you got to distribute that guy, right? We've got cosh of x plus sinh of x over cosh of x minus sinh of x. And then now since I see, okay, the right-hand side, I got an e to the 2x. So I want to switch everything to being written in terms of e, powers of e. So I know cosh of x, that's e to the x plus e to the negative x over 2, plus sinh of x, that's e to the x minus e to the negative x over 2. And then in the denominator, I'm going to have the exact same thing, except a minus sign between them, right? Minus e to the x minus e to the negative x over 2. Okay, how can we clean this up? Well, all of those denominators of 2 cancel out, right? You can imagine if you just multiplied the whole thing by 2, it would be gone. And then look here. Look what else we have going on. I have e to the x plus e to the negative x plus e to the x minus e to the negative x. So these two are going to cancel. And similarly, the e to the negative x's in the denominator. Oh no, not those ones. Forgive me. The e to the x's in the denominator cancel. So what are we left with? Well, upstairs, I've got 2e to the x's. Okay. We see you, e to the x. And then downstairs, I've got an e to the negative x. And then this is going to make it a plus e to the negative x. Ooh, so we got 2e to the negative x's. The 2's go bye-bye. E to the x over e to the negative x is going to give me e to the 2x. And we are done. There's the right-hand side. Bam. Okay. So as long as you know how to define hyperbolic, sine, cosine, and tangent, then you will be in good shape for these problems. Okay. We are in calculus though, aren't we? So we're going to do some derivatives now. Yes, we are. So let's see. What is the derivative of hyperbolic sine of x? We can get it on our own, you guys. Come on. You don't need me to tell you. So the derivative of hyperbolic sine, I'm going to use the definition. It's e to the x minus e to the negative x over 2, right? So let's just take the derivative. What's the derivative of e to the x? It's e to the x. Minus, what's the derivative of e to the negative x? It's going to be e to the negative x, but times a negative 1. So negative e to the negative x. And the constant just comes along for the ride. No quotient rule if there's no variables in the denominator, okay? I know you guys love doing the quotient rule, but sometimes I have to tell my students, calm down. If it's just a constant, just bring it along. No need to do too much. And then this is e to the x plus e to the negative x over 2. Oh, does this look familiar? Do you know who this is? It's our good friend Cosh of x. Wow, wow, wow. So that means the derivative of hyperbolic sine of x is hyperbolic cosine of x. Oh my goodness. So let's list out the rest. I won't derive them all for you. If you want to do a few as you're winding down to sleep, go for it. So derivative of Cosh of x is, what do you think? It's sinh of x. There's no negative. I know. Derivative of tanh of x, sec squared of x. Okay, and then here's the rest. Derivative of hyperbolic cosecant, negative hyperbolic cosecant of x, hyperbolic cotangent of x. Derivative of hyperbolic secant is negative sec x tanh x. And derivative of hyperbolic cotangent is negative hyperbolic cosecant squared of x. So like the three big players, sine, hyperbolic sine, cosine, and tangent, they do not have negative derivatives. And then these guys all do. Little different. I know, little different. We got it though. Okay, so let's practice finding some derivatives here. So let's find the derivative of tanh of 1 plus e to the 2x. Okay, so f prime of x, I'm going to have to use the chain rule, right? So derivative of tanh is sec squared. So I have sec squared, leave this alone, 1 plus e to the 2x. Now using the chain rule, I have to multiply by the derivative of 1 plus e to the 2x. Well, the derivative of 1, that's just 0. Derivative of e to the 2x is going to be e to the 2x times 2. So if I put this all together, let's just rewrite it. I have 2e to the 2x times sec squared of 1 plus e to the 2x. Here we go. Okay, that's it, not too bad. Next one is y equals x times hyperbolic cotangent of 1 plus x squared. So what rule do I have to use here? Can you tell? We have to use the product rule, right? Because I have x, that's one function, And then hyperbolic cotangent of 1 plus x squared is another function. Okay, here we go. So dy dx is equal to, let's take the derivative of x, and then I'm going to leave hyperbolic cotangent alone. Leave them alone. Plus, now I'm going to leave x alone. Take the derivative of hyperbolic cotangent. What is it? It's negative hyperbolic cosecant squared. You're going to leave this 1 plus x squared alone. And then now by the chain rule, you're going to multiply by the derivative of 1 plus x squared. So what's that derivative? Derivative of 1 is 0. Derivative of x squared is 2x. Okay, that's it. So now let's just rewrite it nice and neat. So dy dx equals hyperbolic cotangent of 1 plus x squared. And then I'm going to write this as negative 2x squared. Do you see that? So we have negative 2x squared hyperbolic cosecant squared of 1 plus x squared. Voila. Okay. Let's look at another one. Maybe one more spicy one, huh? We've got y equals the 4th root of 1 plus tanh x over 1 minus tanh x. Ooh, okay. So dy dx, remember this is everything raised to the 1/4 power, right? So you're going to bring the 1/4 down in the front. Write your blank parentheses first and subtract 1 from the exponent so you don't forget. I can't tell you how many times students forget to make that a negative 3/4. Then rewrite what was inside. Don't touch it. Don't touch it. 1 plus tanh x over 1 minus tanh x. Now we're going to use the chain rule and multiply by the derivative of what's inside. And what rule do I have to use? Quotient rule. Yes, very good. So here we go. We've got low d high. Okay, derivative of the numerator. Derivative of 1 is 0. Derivative of tanh x is sec squared x. So that's low d high. Low d high minus high d low. So that's 1 plus tanh x. That's high. And then now I need d low. So derivative of the denominator, derivative of 1 is 0, and then the derivative of negative tanh x is going to be negative sec squared of x. Got it? Square at the bottom, and away we go. So 1 minus tanh of x squared. Close her up. Lovely. Okay, let's see here. In the numerator, if I were to distribute, right? Distribute, this would be sec squared of x minus tanh x sec squared x plus, oh, see that? Because these two negatives, plus sec squared x plus tanh x sec squared x. So I did that to save us some time because notice, this term cancels out. Okay, I like it. So now let's start cleaning up. So we've got 1/4. Now watch this. I'm going to make the exponent positive 3/4. See that? And then you got to flip the expression inside the parentheses when you do that. So this is 1 minus tanh x in the top now and 1 plus tanh x in the bottom. And then over here from the quotient rule, all I have left over in the numerator is 2 sec squared of x over 1 minus tanh of x squared. So that cleaned up big time. Whew, what a relief. Okay, what else can I do? I'm just having so much fun canceling. Okay, so the 2's gone, and now this 4 becomes a 2. And then notice actually, ooh, this is cool. So this is 1 minus tanh of x squared, and this is 1 minus tanh of x to the 3/4. So I can combine those and cancel out the 3/4. Yes. So we're going to have over here 1/2 times, I've got such squared x in the top. I'm going to separate these. So I've got 1 plus tanh x to the 3/4, and then 1 minus tanh of x to the 2 minus 3/4. So that's going to be to the 5/4. Okay. Good. So you could leave it like that, or if you want to rewrite everything with radicals, then you would have such, don't forget the h, such squared x over, here we go, 2, this would be the 4th root of 1 plus tanh x cubed, and then 1 minus tanh of x to the 5/4. Well, I could take out 1 tanh of x from that 4th root, and then you've got 1 left over. So that would be the 4th root of 1 minus tanh of x. It doesn't really matter. I mean, I'm fine if you just stop here pretty much. Okay, but just check with your instructor and see how they want it. Go with what the back of the book does if you're not given other direction. All right, good. One last idea. Hang in there. So we've got inverse hyperbolic functions because, I mean, why not? So here's their definition. It should make sense because if the hyperbolic functions are defined in terms of e, and we know exponential and logarithmic functions are inverses of each other, then wouldn't the inverse hyperbolic functions be defined in terms of natural logarithms? Yes, it should make complete sense. Okay. So there's the definition of just the inverse hyperbolic functions, and then here's their derivatives, okay? Very similar to the derivatives of our inverse trig functions. If you're one of my students, I'm going to give you these, so you don't need to memorize them, but if someone else is your teacher, just check with them. Okay, so let's find the following derivatives. Y equals x squared times sinh inverse of 2x. All right. Don't get scared. Don't get scared. We got this. We have to use product rule though, right? There's x squared. And then there's sinh inverse of 2x. Okay. Y prime is going to equal, let's take the derivative of x squared. And then you leave the other function alone. Plus, now I'm going to leave x squared alone. Let's look at derivative of sinh inverse. So you take the argument, you square it, add 1, put a square root in the denominator. Okay, here we go. So I got 1 over, in this case, it's radical 1 plus 2x squared. And since the argument was not plain old x, I have to use the chain rule and multiply by 2, the derivative of 2x. All right, that's it. Let's just write it a little nicer and we're done. So we've got 2x sinh inverse of 2x plus, I'm just going to put 2x squared together in the numerator over rad 1 plus 4x squared. And that's it. Okay, so these aren't long drawn out problems. Just make sure you know how to use the definition and their derivatives if they were given to you. Okay, I got one more fun one. I promise it's really fun. You're going to love it. Y equals x tanh inverse of x plus natural log of rad 1 minus x squared. So product rule time, right? Because you've got that x, and then you've got the tanh inverse of x, and then the ln rad 1 minus x squared, that's just a chain rule. So y prime equals derivative of x is 1. Leave tanh inverse of x alone. Plus, now leave x alone. What's the derivative of tanh inverse of x? You can check back in your notes. It's 1 over 1 minus x squared. That's his derivative. Okay, cool. Now derivative of ln of rad 1 minus x squared. So derivative of ln of something is 1 over the something. Here's the something. And then by the chain rule, I have to multiply by the derivative of rad 1 minus x squared. Well, what's that? That's going to be 1/2 times 1 minus x squared to the negative 1/2 times by the chain rule negative 2x, the derivative of the stuff inside. Or you could use the shortcut if you remember from my previous video. Okay, so let's see, we've got tangent inverse of x plus x over 1 minus x squared plus, so notice the 1/2 and the 2 cancel. This is to the negative 1/2, so I'm going to put it in the denominator as well, and I've just got an x in the numerator. So I've got actually a negative x in the numerator. My goodness. And then I have rad 1 minus x squared and another rad 1 minus x squared to meet him. Well, this is just 1 minus x squared. Do you see? Do you see what we can do? This is the same term as this. So they just cancel out. Goodbye. Goodbye. And we are left with tangent inverse of x. Oh my goodness. Someone wrote that problem so it would turn out fun like that. See? So we thank them because that was thoroughly enjoyable. All right, that concludes the lesson. So hope you enjoyed it, and that also finishes up the unit that we started on our introduction to differentiation. So we're going to look at more applications of differentiation coming up next, curve sketching, all that good stuff. So stay tuned, and please give this video a thumbs up, subscribe if you haven't already. It really helps support my channel, and I hope you enjoyed it. Happy studying!